one, we're going to find the Taylor series for f of x centered at the given value of a equals 3. F of x equals e to the power of 2x. So we're going to expand it using the Taylor series generated at a equals 3 using this. So we're going to have to crank out some derivatives. So we'll start where n is 0. So this would be the first term. So that's just going to be f of 3 because our a equals 3. So f of 3 equals e to the power of 2x. And we're evaluating where x equals 3. So that's going to equal e to the power of 6. Okay, now for the second term here, which is actually the first derivative at 3, that's 2e to the power of 2x. Evaluated x equals 3. That gives me 2e to the power of 6. All right, let's do the second one. F double prime of 3. That gives me 2 squared e to the power of 2x. Evaluated at x equals 3. That gives me 4 e to the power of 6. All right, and the third derivative is going to be equal to 2 cubed e to the power of 2x. Evaluated at x equals 3. It's going to equal 8 e to the power of 6. Let's do this one more time. We can easily see what it's going to be. We start seeing the pattern here. So this is going to be 2 to the 4th, e to the power of 2x, and you evaluate this at x equals 3. This gives you 16e to the power of 6. Now, for our formula here, we have this equals the sum n equals 0 to infinity, and we have our nth derivative at 3 divided by n factorial times x minus 3 to the power of n. So that's what this is, or this one. All right, now that we have that, let's expand this and see what we actually have. So let's expand it. And I'll duplicate here. All right, so we're going to get this equals e to the power of 6 divided by 0 factorial times x minus 3 to the power of 0. It's not written there, but that's what it would be like. So plus 2e to the 6th power divided by 1 factorial times x minus 3 to the 1st power plus 4e to the 6th divided by 2 factorial times x minus 3 squared plus 8e to the 6th divided by 3 factorial times x minus 3 to the power of 3 plus 16e to the 6th divided by 4 factorial. Then we have x minus 3 to the power of 4 plus it continues on and on. You could see the next one would be 32 and see everything. So let's simplify what we have here. This is going to give me the sum n equals 0 to infinity. Now, all of these are going to be 2 to the power of n. All right. Then we still have e to the 6th. And our denominator is just going to be n factorial because we just keep doing that. So n factorial. And then we have our x minus 3 to the power of n. The next thing we have to do is find our radius of convergence. So we're going to use the ratio test. And again, we had, let me write this really fast. So 2 to the nth power e to the 6th. All right, so we had that. Now the limit, or the ratio test, is the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n. That equals the limit as n approaches infinity. Now let's substitute everything in. So first we're doing a sub n plus 1. So that's going to be for our 2 to the power of n plus 1 times e to the 6th. This is in the numerator. So this is going to be x minus 3 to the power of n plus 1 divided by n plus 1 factorial. Now for a sub n, that's divided, so we're just going to multiply by the reciprocal. So multiply by the reciprocal, we're going to get n factorial divided by 2 to the power of n, e to the power of 6, and then we have x minus 3 to the nth power. All right, now we can simplify all this. Most of it is pretty simple. So let's look at this piece. If we look at that, this is n factorial, and I can expand this to write this as n plus 1 times n factorial. So that cancels out. So that's going to cancel out, and I get n plus 1. All right, now let's look at the numerator part. We have 2n plus 1 and 2n. So when you divide those out, you're just going to get 2. Because this is like 2 times 2 to the nth divided by 2 to the nth. So that cancels out. And let's see, the e to the power of x's cancel. And the same thing happens with this. We're just going to get the absolute value of x minus 3. And this equals 0, which is less than 1. So as this number gets larger and larger, this goes to 0. Since it's less than 1, it's the radius of convergence is infinity. So this is for all x. Thank you. Have a nice day. Bye-bye.